Welcome to this Queensferry Benchmark and Sundial Walk talk. Queensferry Heritage Trust has a guide available for this walk and also a tick list and quiz, and I'll tell you how to download them at the end of the talk. And I will also try to answer any questions you have at the end of the talk as well. Right, so the walk is a quirky circular tour and treasure trail of South Queensferry to find the Ordnance Survey benchmarks and sundials around our town. I'm sure many locals and visitors will have trudged their way around Queensferry during the COVID lockdown, and the goal in making this walk was to give you something different to find and examine. I'll try to explain what benchmarks are, if you've not come across them, and cover some of the history of the Ordnance Survey, who chiselled them into our buildings and walls, and also feature some of the locations on the walk. But firstly, I have to give you a couple of cautions. Queensferry is a popular destination, as I'm sure the current audience all knows, with busy roads. Please take great care when crossing roads. Don't just look at the guide. Also, some of the benchmarks on the walk are on private houses, so rather than alarm the residents by close encounters with walkers, we request you pass them by and move on to the next location. Right, what is a benchmark? Essentially, it's a way of recording the height above average sea level at a particular location. There are various types of benchmark, but the basic one is called the cut mark. And this is the one on the Hawes Brae on the current slide. The cut marks were first introduced in the 19th century, and they have a horizontal slot at the top and an arrow underneath. So a benchmark could fit into this slot. So imagine that this is called the bench or angle iron. That could fit into that slot, and then a surveyor can put a leveling pole onto the bench, and then any surveyors who are working with the team can then take and find the height and location of any spot. So basically, you have benchmarks, you have a bench that goes into them, and you take heights and positions from that. So there were about 750,000 benchmarks created across Britain, but we've lost a third of them due to demolitions, structural changes, and road levelling. And we've lost quite a few in Queensferry. Benchmarks like this are no longer used by the Ordnance Survey. The last one was actually created 28 years ago. The arrow underneath the slot is the broad arrow, a symbol of government property. They were marked on convicts' clothing, but did it indicate the government owned the clothing or the convicts? I'll let you decide. It was also used to mark government equipment. You can see it down here. And it remains to this day an offence to use the broad arrow symbol without government permission. Another type of benchmark you will find on the walk is the flush bracket. And this is the one at Harry Ramsden. They were first used in Scotland in 1936. And we have one at Dalmeny Station and this one at Harry Ramsden's. And they have a smaller bench, as you see in the bottom right here, that clips on for taking measurements, so it could be more accurate. A third type of benchmark on the walk is the bolt, and that's at the top right-hand corner, a variation of the cut mark. The bolt enabled a more accurate height reading, and this one is on the High Street clock tower. Benchmarks such as the three at the top were primarily used to measure heights, but they also had accurate positions. To accurately measure positions, trig pillars, that's the one at the left, and fundamental benchmarks were used. Note that the trig pillar has a flush bracket, so that allowed a height measurement as well. In today's digital world, Google provides easily accessible maps to find locations, to identify routes, and to measure distances and times. But Google Maps do lack detail. For hill walking or detailed layout or contour information, Ordnance Survey maps are the best. So how did the Ordnance Survey create these maps? We have to go back to the 18th century to see how this started. The principal triangulation of Britain was the first high precision survey of the whole of Great Britain and Ireland, and it was carried out between 1791 and 1853, so it took 62 years to do that. And the aim of the survey was to establish precise geographical coordinates of almost 300 significant landmarks. And from these landmarks, local surveys were made from which all the maps were created. So what do we mean by triangulation? If you wanted to place 4 locations, say A, B, C, and D, on a scale map, you might start at A and measure to B, and that's called your baseline. From A and B, you can then measure to C, the angles, using a theodolite or similar instrument. And with these 2 angles, you can find the position by calculation or by simply drawing the angles on your scale map. And likewise with D, you now have a baseline from B to C, measure the angles, Bob's your uncle, you've got position D. And so you just need to repeat that all right across Britain and Ireland to measure the 300 locations. And this is maybe why it took 62 years. A problem during the principal triangulation was the exact location of some of the surveying stations were lost. So between 1935 and 1962, the Ordnance Survey carried out the re-triangulation of Great Britain to improve the accuracy of their maps. A network of permanent surveying stations were built using these mainly concrete pillars, triangulation pillars or trig pillars, they're known as, 6,500 of them, which you may have come across on hilltops or mountaintops. Trig pillars are now obsolete. The Ordnance Survey has gone whizzy and uses satellite navigation systems. What took hours to measure in the 1930s can be achieved in seconds now, and to an accuracy of just a few seconds. Having worked out where everything was, the Ordnance Survey then had to work out all the heights above mean sea level, and they did this by a process called levelling, and this is where the benchmarks were used. The first levelling of Scotland took place from 1844 to 1860. I don't have a map of that, but this map shows the third geodetic levelling, which took place from 1950 to 1968. By the way, geodetic means the surveying was so accurate it actually took account of the Earth's curvature. So each levelling survey had a mean sea level reference location, it's called a tide gauge point, which was initially at Liverpool, but later at Newlyn in Cornwall, which is right down in the toe of Cornwall. And they measured there the sea level every 15 minutes for 6 years. The brass bolt in the photograph is the benchmark for the whole of the United Kingdom. And that is all heights and all sort of Ordnance Survey maps are now referenced to that point. So it's clever stuff. The process of levelling uses an optical level, which is a simpler version of a theodolite. It's just got a telescope and a spirit level. So if you have benchmark 1 and you wanted to find or create another benchmark, benchmark 2, you could use an optical level, even if there's a hill in the way. That was the actual process. There is one type of benchmark still in use by the Ordnance Survey, and that's the fundamental benchmark. Now, our nearest one is located in a small wood at Rosyth. I went with Marion and Len Saunders to find it. Len and I started to search through the wood, but Marion had the bright idea of standing on a small hill and spotted it straight away. Well done, Marion. There are nearly 200 of these fundamental benchmarks around Britain, mostly constructed in the first half of the 20th century, but they are like icebergs, 90% is below the surface. The visible part is the small concrete pillar you can see, and it has a bolt and an Ordnance Survey plate in it. But what is underneath? Below the surface is a concrete chamber resting on bedrock, and the chamber contains a second brass bolt and a polished flint. Websites tell us the relationship between the flint and the 2 bolts is known only to the Ordnance Survey, so we have a bit of a mystery there. So where are our benchmarks? Some are on buildings, some are on walls, and some are quite hard to find. So we've added pointers to the photos in the walk guide. This one in the Priory Church is tucked away at the bottom left-hand corner of the church and near the pavement. A lot of them are actually quite near the pavement. And of course, we've passed it every day without seeing it. The flush bracket at Harry Ramsden is obvious once you know where it is. And this bolt, highly prized by benchmark collectors, and I'm afraid there are such people, is on the clock tower. And I suspect the railings were a later addition because you couldn't really get the bolt in, the bench in there. If you'd like to find benchmarks in other areas, there's a very useful website at benchmarks for-our.info map.html. It also shows the other less common types of benchmarks, such as rivets and pivots. And you can click on a benchmark to bring up the detail, as I have here, and then clicking on the grid reference will take you to another website with more details, or the lat long will actually give you quite a nice detailed map of where it is. So why and how did the Ordnance Survey and benchmarks come about? Well, the official answer is that the Ordnance Survey was founded in 1791 when Kent was surveyed to record military facilities and create an accurate record of the landscape in case this chap invaded. But this misses out a whole chunk of surveying and map-making history which happened in Scotland by Scots, and due to an actual invasion by this chap, Bonnie Prince Charlie. Isn't he bonny there? During and after the 45 rebellion, the Redcoats had great difficulty in suppressing the rebellion in the Highlands. The Highlanders knew exactly where they were and were very familiar with local landscape. But the Redcoats often hadn't a clue where they were due to the lack of detailed and accurate maps. After the 45 Rising, it was obvious that there was a need for an accurate map of the Highlands. Colonel David Watson, a military engineer, deputy quartermaster of Scotland, proposed that a full survey of the Highlands be made. Watson employed William Roy, a civilian assistant, to carry out the work. Now, Roy's family had been factors on the Hallcraig and Milton estates in Lanarkshire for generations, and Roy would have been very familiar with surveying. Roy's military survey was limited by the availability of men, equipment, and time. The Board of Ordnance, who were in charge of such things, were rarely able or adequately finance the actual work, and Colonel Watson paid for much of the survey himself. This was the first time the Scottish mainland had been mapped at the same time and in the same way, and it took just 8 years, which by Ordnance Survey standards is actually quite short. Here's a typical map of Scotland at the time of the Jacobite uprising by James Dorrit, 1750. Loch Ness is clear, but there is little detail. And if we can compare it with a Google satellite map, we see that Loch Ness is approximately right, but the features on the map seem to have little relationship to what's on the ground. Now compare that satellite map with Roy's map, and we see Roy's map matches up very accurately with the loch and the terrain. So I think you'll agree that Roy's map looks like any modern map of Scotland, and probably for the first time of any map produced. And all this was achieved with simple instruments and techniques and on a limited budget. Roy knew that much more accurate surveying could make much better maps, and he dismissed his map as a magnificent military sketch. Roy then enlisted in the army, became a very competent surveyor, and he proposed in 1763 an accurate survey to create maps for the defence of the whole of Britain in case of French invasion. The proposal was rejected on grounds of cost. In 1783, though, Roy got his chance to demonstrate accurate surveying when this man, Jean-Dominique Cassini, director of the Paris Observatory, dared to suggest that Greenwich was not where Greenwich thought it was relative to the Paris Observatory. It was proposed to the Royal Society of London that a high precision triangulation between Greenwich and Paris be undertaken. The Royal Society agreed, and jointly with the Board of Ordnance, they invited Roy to take charge. The Anglo-French survey started in 1784 and took 6 years to complete. Roy wanted a very accurate theodolite, accurate to within a second of arc. That's 1 second of 1 minute of 1 degree. Perhaps the only person in Britain who could design and make such an instrument was this man, Jessie Ramsden. Roy ordered such a theodolite from Ramsden, and it was delivered in 1787, the most accurate and largest theodolite ever constructed. Ramsden was a perfectionist. He infuriated his clients as he continually refined his designs, causing many delays. The theodolite was delivered 3 years late. To make such an instrument, Ramsden had to make another instrument first, a dividing engine, which did all the marking of the fine lines, and his arm rests upon this in his portrait. Despite its massive size, Ramsden's theodolite was carried from London to the Channel coast and used on hills, steeples, and a movable tower. The triangulations were measured many times, often at night to avoid atmospheric distortion. Then spherical trigonometry was used to calculate the triangles, and that's when things start to get rather complicated mathematically. The final results were actually inconclusive, for triangulation was not quite as accurate as the best astronomical measurements. But the survey paved the way for all future work in terms of high precision and the techniques for calculating the curvature of the Earth. In his final report, Roy pressed yet again for the extension of the survey to cover the rest of Britain. And so we come back to this chap and the threat of the French invasion. And on June 21st, 1791, the Board of Ordnance finally recognised the threat and purchased another Ramsden theodolite. This action is taken as the inauguration of the Ordnance Survey. Incidentally, I notice we've just passed the 230th anniversary of this event on Monday. And so in 1791, the first Ordnance Survey map was started in Kent, an entirely new and accurate survey of the county of Kent with part of the county of Essex, and it was completed in 1801. And the principal triangulation of Britain, which we saw earlier, also started in 1791, and that's how the Ordnance Survey benchmark came about. So next time you pick up an Ordnance Survey map, just think about the huge human endeavours it took to produce these maps. We produced our own little map for the walk, which is on the rear of the walk guide, not quite up to Ordnance Survey standards, but it shows you the route and highlights the locations on the walk. Our walk has 17 locations, 9 visible benchmarks, 4 missing or not accessible benchmarks, 3 sundials and 1 viewpoint. The walk is a circular tour, so you can start at any point, but our nominal starting point is Dalmeny Station. Let's have a look at a couple of the locations. The first location is Dalmeny Station. It opened in 1890 as Forth Bridge Station, but this name lasted for only a few weeks. Note the smaller building in the foreground, presumably a waiting room. Does it look at all familiar? When the waiting room on the other side, and originally we had a waiting room similar to that one which is on the west side, on the east side, when that burned down in a fire in the 1980s, it looks like they moved this one across to replace it. Although the opening of the Forth Bridge enabled new railway routes to be created and shortened journey times than existing ones, North and South Queensferry lost all the through traffic which had previously used the ferry to cross the Forth between stations. This, together with the loss of trade and jobs at the end of the bridge construction, had a significant financial impact. Here we see what looks like the station staff and their family at the original ticket office. The station footbridge over the line was a later addition. Initially, to get to the other platform, passengers climbed this covered walkway under the rail bridge, and you can still see the marks on the wall where it was. Now, who is this lovely lady? This is Candida Louise Bertolucci, the Marchioness of Tweeddale, and she was the first person to drive a train across the Forth Bridge. She took command of the controls at Forth Bridge Station 24th of February 1890, just before the opening, and drove the train, a director's special, right across the bridge. She was commended on her driving skills by the Superintendent of the North British Railways. Her husband was chairman of the North British Railway and a director of the Forth Bridge Railway Company. I should point out this was not her outfit on the day. The Scotsman reported she wore a seal coat, a wise choice when you consider the exposed driving position on Victorian engines, as you can see on this very similar engine which pulled the Prince of Wales train at the opening of the bridge 5 weeks later. Now, the third location on the walk is at the east end of Station Road. These semi-detached cottages appear to have been the chapel for the Forth Bridge workforce. There is, or was, a benchmark at the east end of the building, but this is one of the benchmarks on private land, and we ask walkers not to intrude upon this. Behind you, or behind this view, if you like, was a great big field, well, there is a great big field, which in the 1880s was the Forth Bridge manufacturing site. And we have this map of it. So there's the railway to Port Edgar, which is now the cycle walkway. On the left-hand side, we've got Station Road coming down to Bankhead Road, not Dalmeny Road as it says on the map. Go along Bankhead Road on the walk, and then you're down the Hawesbury to the Forth. The site had a drawing loft to make actual size wooden templates or Forth Bridge parts. There were also cement stores, timber yards, joiners and carpenters shops, a grocer's shop, a clothing and boot store, engineers and managers' offices, and a pattern shop. There was even a small village of 16 brick houses and 40 wooden huts to accommodate part of the workforce, as well as about 60 tenements for more of the workforce. At its peak, the site covered 60 acres. And if you're wondering why it's all in German, the map comes from a German book about the Forth Bridge. In the centre are what were called the drill roads, meaning railroads. And here we are, the Forth Bridge Works, the drill roads. Here on the drill roads, William Arrol's ingenious multi-head drilling machines, and you can just see one at the far right, went along. They operated drilling the great 12-foot diameter tubes to ensure that the steel plates fitted exactly when assembled on top of the bridge. The drilling machines were powered by steam engines and could drill 10 holes at a time. And that was important, as there were up to 8 million rivets used on the bridge. Now that would require at least 16 million holes to be drilled. Once all the holes were in place, the steel plates were unbolted and taken to the bridge. So they said the bridge was built twice. Walking along Bankhead Road here, you would pass what is, I think, now the farm building, or well, there's the brewery and various other bits. But in 1917 or 1918, you might have met these sailors from the American fleet based in the Forth. And it looks like they're collecting milk and befriending the young girl, presumably the daughter of Bankhead Farm. Just going back to the Forth Bridge. So you've come along. That at the far left is the German for chapel. That's why I think that's the actual chapel, those two cottages. So you come along and then you turn onto the Hawesbury, careful crossing the road. And there are two buildings here. These were the houses used by the Forth Bridge managers and engineers. And we actually have a photograph of the Forth Bridge engineer's house, and it was decorated for the Shah of Persia's visit to the Forth Bridge in 1889. And I think the two lads at the right here have been given the task for building it, and they're probably apprentice engineers. Now, although this house, which looks quite fine, was built by William Arrol, notice that the bricks look second-hand or rejects, which they probably were. Lord Rosebery had stipulated that the whole manufacturing site, which was massive, including these houses, had to be removed from his land when the bridge was finished. Not all the Forth Bridge buildings were removed. You'll pass these buildings on the walk, apart from Catherine Terrace. which was demolished, I think it was in the 1960s. Catherine Terrace and Ross Hill Terrace were used for foremen and leading hands. The other two, Bridge House and Forth View, were used by Fowler, Baker and Arrow and their engineers and important visitors. So these are all brick buildings. Was it the railway and the Forth Bridge that first brought brick buildings to Queensferry? Possibly. The next benchmark is on the pavement side of the Hawes Brae, and it's hard to find. So to locate it, walk down the Hawes Brae from the top there, and until you're opposite the Z Ben's road sign on the other side of the road. Then take 10 paces down the hill and you should find it at your feet. The Hawes Brae was once part of the Cramond to Queensferry Turnpike Road, and that was created in 1751, and it's actually the first turnpike road in West Lothian. As the Industrial Revolution developed, it became apparent that better quality roads were needed. The turnpike roads were the high-speed rail of their day. For example, the Holyhead Road, now the A5 down in England, built in the 1820s and using Thomas Telford's road-making system, reduced the journey time of the London mail coach from 45 hours to 27 hours. And the best mail coaches' speed rose from 6 miles an hour to 10 miles an hour. Telford was, after this, referred to as the Colossus of the roads. Turnpikes were funded by Acts of Parliament, as this 1811 Act for the Cramond to Queensferry Road. The Act enabled a trust to be set up with trustees who were local councillors or local landowners. The trust borrowed money to build new turnpikes or repair existing ones, and then levied tolls on roads. This 1811 Act extended the turnpike to Linlithgow, so the turnpike came into Queensferry and then back out again. Tolls were very complicated and depended on the type of vehicle, the number of horses, the number of passengers, both inside and on top. Stagecoaches could be charged on this turnpike between £4 and £40 in today's money. In this Act, the toll collectors had nearly 30 categories of charges, as shown. I've listed these on the pages on the right-hand side. Coaches with wider, flatter wheels were charged half price as they caused less damage to the roadway. At the end of each turnpike road, and sometimes at various places along them, there was a toll gate, a toll keeper's cottage. Our toll gates have long since gone, but this rather nice postcard shows the toll gate and the toll keeper's cottage. There is a large sign there, white sign, and that would have all the charges, toll charges listed, and also notice the gas light because traffic went through at night. The Cramond toll may have used one of the cottages at Cramond Brig Toll, bit of a clue there, but we can only guess where the Queensferry toll gates were. They may have used some of the Dalmeny houses, or the toll gate houses may have disappeared. The great advances in British roads at the beginning of the 19th century were due to two Scottish engineers, Thomas Telford and John McAdam. Telford's road had a large trench with a foundation of heavy rocks and a surface of broken stone with a camber to improve drainage. Telford's road significantly reduced the journey times, as we saw earlier, but they were very expensive. McAdam's design used soil and smaller stones, and his roads were simpler, lower cost, yet more effective at producing roadways and twice as strong as Telford's, some people thought. Incidentally, McAdam's nickname was Tar McAdam, not because he used tar on his roads, which he did not, but because he managed the British Tar Company over in Couros, over in Fife. And the works were started by this man, Archibald Cochrane, 9th Earl of Dundonald, and he had actually invented and patented the process for making tar from coal. Modern tarmac roads were created by the Welsh engineer Edgar Hooley, who noticed that tar spilled on a roadway created a smooth surface with no dust, and he patented the tarmac road in 1901. If only McAdam had thought of using tar on his roads 100 years earlier. There are many other interesting locations and stories on our walk, but our time is limited tonight. So I'll move on to just the 3 sundials. There are many types of sundials, and they come in all shapes and sizes. The vertical and horizontal ones are the most common, but there are more exotic types. However, they all work on the same principle, or modern ones do. The gnomon, that's the sharp pointy bit, casts a shadow onto the dial marked with the hours. If you've ever read the time in a sundial, you'll find you do not agree with your watch. And that's because sundials work on local solar time, whereas our watches work on Greenwich Mean Time. Sundials used to be, sundials need to be designed, made and installed for a specific location. And incidentally, they use the same mathematics as surveying. Scotland has some of the best multi-face sundials, often constructed as pillars, such as this rather nice one at Drummond Castle. They can have over 50 dial faces, and really they were just showing off. You only need one. We have 3 sundials in our walk, the first 2 at the Hawes Inn and another visible from the top of McIvor's Brae, and they're in very poor condition, as you can see. Most of the gnomons are missing. They're both scientific sundials, meaning that the edge of the gnomon, which casts the shadow onto the hour, and you can work out the hours, is parallel with the Earth's axis of rotation. And this makes the hours the same length throughout the year. And the invention of scientific dials in the 14th century is attributed to this chap, Ibn al-Shatir, who was a mathematician and timekeeper at the Umayyad Mosque in Damascus. Times of prayer are very important in Islam, and he was trying to make them more accurate. And this is one of the reasons why there was so much development in the Middle East in mathematics. The 3rd sundial in the Priory is much older and is not a scientific dial. So just looking at the Hawes Inn sundial, it's at the west end, at the back, high up. And I must admit, I've passed it for many years without being aware of it. Vertical sundials can face in almost any direction, but a sundial facing directly south is easier to make, as this one does, hence the angled position. There's a corresponding dial in North Queensferry, and they could have been used by the ferries. They both have dates. South Queensferry is 1780 and North Queensferry 1778. The second dial can be viewed from the top of McIvor's Brae if you look towards the Forth Bridge. Vertical dials read a maximum of 12 hours, but of course our summers exceed that limit. The simple way to overcome this is to have 2 sundials, as this one does, one declining to the west and one declining to the east. In this case, the left one reads from 10 in the morning till 8 p.m. and the other from 6 in the morning to 5 p.m. and that extends the range to 14 hours. This sundial is on the remains of the chimney of Bridgewatch House, which is just opposite the Seals Craig, and it's in a rather poor state. But we can get some idea of its former glory when there was a chimney on the house. This is the diagram here, and this is from the wonderful Gibbons and Ross, The Castellated and Domestic Architecture of Scotland, published in 1887. Our 3rd sundial is on the south side of the Priory Church, near the bottom right-hand corner, and I'll just try it. You can probably just see it in that image there. There's a close-up of it. This is a scratch dial, so called because they were simply scratched onto a south-facing wall, possibly by the priest, and were also known as mass dials because they mark the canonical hours of prayer. The gnomon was just a short wooden peg that was put in the hole. There's obviously not one in this, and it was not a scientific dial, as the gnomon did not point to the north, so the hours and hour lengths would vary throughout the year. This type of sundial was used in Britain during the Middle Ages, and until scientific sundials were brought back from the Crusades. There are reckoned to be about 3,000 scratch dials in England, but only about 10 in Scotland, so they're very rare. Now, you might think that clocks made sundials totally redundant when they appeared in the 17th century, but they were very expensive. And how did they reset a clock or check the clock's time? There were no Pips or Tim in those days, but on a sunny day, a sundial could be used. And so that brings me to the end of the talk about our walk. I hope you've had some idea of what benchmarks and sundials are all about. You can download our free walk and the tick list and quiz from the walks page on our website, which I'm sure you all know is queensferryheritage.org.uk. The guide can be printed out as an A5 booklet or A4 sheets if you like larger print, or if you download it to a smartphone, you can then just use it on the phone. The tick list and quiz is suitable for both younger and older walkers, we hope. I'd like to thank the other members of our QHT benchmark team. That's Ian Harrower, Tony Jones, David Lerman, Stuart Ridge, and a special thank you to Mark Meredith, who did all the text in the guide. And also to thank our QHT committee for their support. If you walk the walk, we'd welcome any feedback, good or bad. And lastly, thank you for listening, and I hope if you walk the walk, you'll find it enjoyable. I'll now hand you back to David and we can take questions.